My senior project was designing an efficient propeller by prototyping with 3D printing. So reducing global warming and carbon emissions are one of the largest challenges currently faced by humanity. And in order to accomplish this, carbon emissions and power consumption must be reduced in every facet of our society. Most passenger aircraft are powered by fossil fuels. This means that any increase in the efficiency of the propulsion of these aircraft will directly decrease carbon emissions. For my background research, I found that the cost of 3D printing has been consistently decreasing over the past 15 years, while the 3D printing industry has rapidly grown. In my research, I also found a study that attempted to find any differences between the efficiency of identical propellers, except for one was an injection molded propeller and one was 3D printed. They found that the efficiency of them were basically the same. So 3D printing is a technology that can be used for prototyping propellers. So for my design process, the first step was creating my testing apparatus. So as you can see in the bottom right-hand corner, I had a vernier force sensor, a brushless motor to actually spin the propeller, a speed controller that basically tells the motor how fast to spin, and a power supply that also shows how much current is being drawn. So this setup works by measuring the thrust outputted and the current draw that I will use to calculate the efficiency per watt, the thrust per watt or efficiency, which is a pretty common measurement for propellers. So the second step was creating my initial design. So you can see Propeller 2 and Propeller 3 were my first two designs that I 3D printed at the same time. Propeller 1 would be an injection molded propeller that I used to evaluate my setup and make sure it was working properly and to use as a benchmark for my designs. So Propeller 2 with Propeller 2, I attempted to incorporate some complicated features into it, such as tapering and twist across the propeller blade, while Propeller 3 was much more simple with a 45-degree angled prism for the blade that is just a rectangle with the two ends pointed. So I tested those designs and I found that Propeller 3 was about half the performance or efficiency of Propeller 1, and Propeller 2 was about a quarter of the efficiency of Propeller 1, which is the commercial propeller. So I decided to iterate on Propeller 3 because it had a higher efficiency. So one of the main issues I thought was present in Propeller 3 is that a lot of the air was being pushed sideways and not downward because it had large, flat, vertical surfaces. So I attempted to round those off in different ways, such as this one where I just added a 1-degree curve to every corner, or these two where I rounded off the entire blade. So I found that propellers 4, 5, and 6 were very similar to Propeller 3. However, there were some differences. Propeller 5 had the most consistency across the 3 different speeds that I tested it at, low, medium, and high. So some of the propellers had slightly different efficiencies at different speeds compared to each other, with Propeller 5 having the highest efficiency at the high setting and Propeller 6 having the highest efficiency at the low setting. The conclusion of my project was that I did not fully meet my project goals. Although I did create 5 working propellers, they were less than half as efficient as the injection molded propeller, and my revisions of Propeller 3 did not significantly improve the efficiency. So one of the main reasons I believe that my propellers were not very efficient is that I did not incorporate an airfoil into the design. So if I continued this engineering project, I would incorporate an airfoil into the design. I would also try to implement using computational fluid dynamics in order to calculate the efficiency on a computer program before physically printing them out, which would allow me to design even more without taking time to print them out. One successful part of my project is that it did demonstrate the value of 3D printing as a prototyping technology, because I was able to, within a few hours, physically create a real life version of what I had designed on my computer.